Ay, so using 2 watt meter or double watt meter, so most probably, no, practically, so ito yung pinaka-applicable na ginagamit na watt meter method. So under 2 watt meter, applicable yan, no, pwede mo siyang gamitin to measure balance, to measure power consumed by balance or unbalanced, no? So pwede siya pang balance at saka unbalanced. So under 2 watt meter method, kung meron tayong 3-wire system, so tulad dito, we have only 3 wire, line A, line B, and line C, and let us consider wala tayong ginamit na neutral wire. So, ibig sabihin, parang yung load natin is naka-delta, no? So, or Y ungrounded. So, meron tayong 3 wires. So, under 2 watt meter method, gagamit tayo ng 2 watt meters. So, kaya nga 2. So, ang una natin kailangan gawin dyan, if you are dealing with 3-wire system, so kailangan natin mag-set ng common potential. Kailangan natin kumuha ng common potential. So pag sinabi natin common potential, ito yung isang line na gagamitin natin na same potential or same terminal kung saan connected yung potential coil ng ating dalawang wattmeter. So under common potential, so pwede kang pumili either A, B, and C. So walang problema doon. So let us consider, iset ko na ang aking common potential, sabihin ko na lang is B. Walang problema doon. So ibig sabihin, hindi ka pwede maglagay ng ammeter kay B. Puro potential coil lang ang connected kay B. So in that case, yung ating dalawang wattmeter, connected dito kay A at saka C. So ito ngayon yung ating dalawang wattmeter. So one of the wattmeter, connected ang kanyang current coil kay A. Then its potential coil is connected kay A and B. So ito ngayon yung ating first wattmeter. Let us say this is your wattmeter A. Now the second wattmeter, that is only connected kanino? Kay C. Hindi pwede maglagay ng ammeter or current coil kung doon sa line na sinet mo as common potential. So dito, sinet ko is B, kaya hindi tayo pwede maglagay ng current coil dyan. Puro potential, kaya common potential. So this case, the second wattmeter, its current coil should be at line C, then its potential coil, no, connected din kanino? Kay B, kaya tinawag siyang common potential. So you have now the second wattmeter. So let us consider this is wattmeter C. Yung iba, wattmeter 1, wattmeter 2. So dito, set ko wattmeter C kasi connected siya kay line C. So therefore, same idea, kung saan connected yung voltage at current, yun ang magiging, kung saan connected yung current coil at potential coil ng ating dalawang wattmeter, so doon ang magiging voltage and current na gagamitin natin. So kaparehas kanina, for example, si wattmeter A, sinong voltage ang gagamitin natin, ano? For wattmeter A, kung gusto natin computein, that is voltage between kanino? AB. Sinong current? Si IA. So multiplied mo kanino? Cosine theta. So theta nino yan? BAB at saka theta nino? IA. So same also, pag kinuha mo si wattmeter C, sinong voltage ang gagamitin natin? You have voltage CB. So yung second subscript represent yung common potential. So yung per subscript kung saan connected yung current coil. Tulad dito, AB, current coil is at A, the other potential is at B, kaya BAB. So ito rin, so current coil is at C, potential coil is at B, so therefore the voltage should be CB. Sinong current? So this should be IC. So cosine theta ng angle ng ating CB at saka theta ng I sub C. Sir, wala tayong CB. So CB is the opposite ng BBC. Okay? So ibig sabihin, kung ang BBC natin is nasa negative 120, so nasaan yung CB? Yung kanyang ka-opposite, nasa positive 60. Naku ka ba? Kasi alam natin line to line is AB, BC, at CA. So kapag nagkabaliktad, ibig sabihin, kukunin mo yung opposite. So therefore, pag nakuha mo itong reading na yan, so tatandaan natin, the sum of the two readings of our wattmeter A and wattmeter C, that is always equal kanino? The total 3-phase power. Yan palagi yan for 2 wattmeter. At isa pang advantage ng ating wattmeter, so under wattmeter, hindi lang real power ang na-compute natin or na-measured, pati na yung kanyang power factor, especially sa industrial commercial, kailangan yung kanilang average power factor every month, no? Kasama sa tinitignan yan. So it's too important to identify also their operating power factor. So the power factor angle using the wattmeter, so it is also equal to arctangent of square root of 3 multiplied sa ratio ng wattmeter A minus wattmeter C all over wattmeter A plus wattmeter C. So, yan yung dalawang data na makukuha natin using wattmeter. Makukuha mo yung total power and also the power factor angle. Kaya nakuha din yung kanyang power factor. Nakuha ba? So, this given formula, applicable ito for any corresponding load. Either naka-delta yan or naka-y, balance or unbalanced. That will be the reading of our 2 wattmeter. Now, for balance, ito hindi ko na lang i-derive. This also using phasor diagram. Ngayon, kung ang load natin is balanced load, kaparehas ng ating problem, for balanced load, the reading of our wattmeter, for balanced load 3-phase, reading of your wattmeter always represent voltage, line current, multiplied to the cosine of power factor angle plus minus 30 degree. So, ibig sabihin, yung isang reading, gamitin mo yung minus 30. Yung isang reading, gamitin mo yung plus 30. So, you have now the 2 readings of your wattmeter. However, this given equation, it is only applicable for what? Balance load. So, kaparehas nito, balance yan. So, pwede natin gamitin itong equation na to get the readings of these 2 wattmeter. Since meron naman tayong power factor at alam natin yung line voltage, so kukunin na lang natin yung value ng line current to determine now what would be the reading of this 2 wattmeter. Yung isa, minus 30. Yung isa, plus 30. So, since balance, load, so pwede natin kunin magnitude ng ating IL. Saan natin kukunin? So, using power formula, diba? This is square root of 3 line voltage, line current, multiplied kanina power factor. So, makukuha natin yung line current. So, the line current for this given balanced 3-phase load, you have 20 kilowatts or 20,000 square root of 3, line-to-line voltage, 230, multiplied by the power factor of 0.447. So, this will be the magnitude of our line current. So, 20,000 over square root of 3 times 230 times 0.447. Yung tama, no? 111 or 112.31 ampere. So, next natin, kukunin natin yung power factor angle. So, the power factor angle, that is simply our cosine, whatever the power factor, 0.447. Okay? So, stored ko na lang ito kay A. So, our cosine of 0.447, ano lumabas? So, 63.45. Tama yan, kapatid. Degree. Therefore, pwede natin kunin wattmeter A, line voltage, ilan siya? 230. Line current, nakuha natin, 112. So, 112.31. Cosine, ano yung power factor angle? 63.45. So, gamitin ko minus 30. So, ito yung first wattmeter natin. So, you have 230 of alpha A times cosine of stored ko muna ito, shift stored B para diretso ako mamaya. 230 alpha A times cosine of alpha B minus 30. So you have 21,553.9 watts. Or this is approximately 21.55 kilowatts. So that is the first reading. Now the second reading, wattmeter C, line voltage 230, line current 0.31, then cosine, power factor angle 63.45, Then, gamitin ko naman is plus 30. So, meron tayong answer. So, baguhin ko na lang ito. Gawin ko to plus equal. So, negative 1,553.9 watts, or that is approximately negative 1.55 kilowatts. So, that should be the answer. Kapag pinag-add mo ito, no? Pag pinag-add mo yan, lalabas 20 kilowatts pa rin. Okay? If you add this one, 20 kilowatts pa rin. So, yun ang hinahanap natin sa sagot. Ano letter yan? This should be baliktaran. Okay? So, tanong, Sir, ano ini-indicate ng negative reading? Okay. So, alam natin si wattmeter, dapat positive yan, real power. There are two scenarios. There are two scenarios at which the wattmeter will give negative reading. No? There are two possible scenario. Ano yung dalawang possible scenario? Una, first scenario. So first possible scenario at which wattmeter will give negative reading, that is in case nagkamali ka ng connection. Okay? Kasi sensitive yung current coil at potential coil ng ating wattmeter. So dapat properly connected yan. So kapag nagkabaligtad, let's say, nabaligtad ang polarity ng ating current coil kay C, so negative talaga ang ibibigay na sagot niyan, or nagkabaligtad yung potential coil. Okay? So that is possible. Pag binigyan ka ng negative na reading, so possible na mali yung connection or nagkaroon ng wrong polarity sa connection ng ating wattmeter. So pwede mo ngayon i-check kung tama ba. Ngayon, kung i-double check mo, tama, properly connected yan, so walang reason para magbigay siya ng negative kung properly connected. Ngayon, bakit siya nagbigay ng negative? So negative reading, no? Nagkaroon lang tayo ng negative reading ng wattmeter. It's only because of what? The trigonometric behavior of cosine. So that is because of the property of our cosine functions. Kasi doon natin siya kinukuha. Kasi yung ating cosine, alam natin, the cosine functions will give positive, okay? Will give positive value kapag yung angle natin is less than 90 degree. Tama ba? No? Pagka yung angle natin dito is less than 90 degree, automatic positive ito. Pero kapag yung angle ni cosine is greater than 90 degree, doon siya magbibigay ng negative. So dito, kaya naglabas ng negative yan, tingnan mo, ano yung power factor natin? Power factor angle, 63.45 plus 30. So pag nag-plus 30 ka rito, 93.45, which is greater than 90. So that is already the corresponding behavior of your cosine. Lumabas siya ng 90 degree, kaya negative ang ibibigay sa iyo. Kaya expect mo na negative yung isa. Paano natin malalaman na possible negative yan? That is the indication for the power factor. Pag nagbigay siya ng isang negative, alam mo na kung anong possible range ng power factor. Ito siya. Kapag ang power factor natin, the power factor of the whole system is less than 0.5, ito yung expected mo. One of the given reading is positive. The other reading will give us negative. Okay? So expect mo na kapag ang power factor is less than 0.5, yung isa positive, isa negative. Basta properly connected, yan ang ibibigay na value. But take note, not equal itong dalawa. Okay? Isa positive, isa negative. That is based on the power factor. Kaya meron ka agad idea, ay, ba't negative ito? Tamang sagot, less than 0.5 yung power factor ng ating system. So if the power factor is greater than 0.5, so dapat ang expected natin parehas itong positive. Same positive, but magkaiba ng reading. Okay? Magkaiba ng reading pero parehas na positive. Another, if the power factor is exact 0.5, ano expected mo? Yung isa positive, yung isa zero. Automatic zero yung isa pag 0.5. Now, possible po ba, sir, na mag-equal yan? Yes, possible. Kailan siya? Kapag purely resistive. So, pag purely resistive yung ating load, expect mo na the wattmeter reading parehas na positive, at ano sila, equal. Okay? So, yan ang in-indicate, yan ang indication bakit negative yung isa. Dalawang possible scenario. Una, mali yung connection, nagkaroon ng problema sa connection ng ating wattmeter, or the second scenario, power factor is less than 0.5. Nagets ba? So, any more questions regarding our 2 wattmeter or wattmeter methods? Okay. So, yun siya kapatid, no? Kung bakit nagkakaroon tayo ng negative reading. So, dapat talaga positive yan. However, due to the fact that the behavior of cosine will become negative kapag ang angle niya is greater than 90. So, therefore, expect na natin kapag ang power factor mo is less than 0.5, so the total angle to be evaluated under cosine will become greater than 90. Kaya yung isa, negative. Okay, kuha? So, no more questions regarding wattmeter method. So, basically, the other problem here is just wattmeter. So, kayo nang bahalang magsagot dito, no? So, for number 22, parallel loads. Pag parallel loads, anong gagawin mo lang? Apparent power methods. So, using 2 wattmeter, sinukat yung power consumed by the first load which is in parallel with the second load. So, ang sagot lang dyan, letter A. Okay. So, then 23, you have the 2 readings of your wattmeter. Yung isa, 85.5. Yung isa, positive 34. So, parehas silang positive. So, pag parehas positive, unequal, ano power factor? Greater than 0.5. So, saan mo kukunin yung power factor? So, ito siya kapatid. No? Power factor angle is arctangent of square root of 3 wattmeter A minus wattmeter C over wattmeter A plus wattmeter C. So, ito yung formula nyo kay number 23. So, makukuha mo dyan 80.69 if I'm not mistaken. Okay, so dito, same yan. Si number 24, kapares nitong sinolve natin. Balance, 3,000, may power factor. So, hinahanap yung 2 readings. Sir, dito sa 24, wala pong binigay na voltage. Paano namin kukunin yung wattmeter using this equation? So, kung wala si voltage, gamitin mo yung general formula. Nasaan yung general formula natin? Ito yung ating general formula. Lalabas dyan, 2 equations to ano? Wattmeter A plus wattmeter C, ano siya? 3,000. So, meron tayong power factor. So, tangent mo to, tanggal yung tangent. Divide ko ng square root of 3, cross multiply ko. Wattmeter A plus wattmeter C, sino yung total power? So, second equation, wattmeter A minus wattmeter C equal sa total power over square root of 3, tangent of the power factor. So, meron kang 2 equations to unknown. Ito pa rin yung equation na gagamitin natin. Okay, so ang sagot dyan, if I'm not mistaken, it should be 850 or 950 yata. So, andyan lahat sa sagot. Okay, so try nyo na lang. Ito na yung mga formulas natin for 23, 24, and 25. So, kailangan lang natin i-identify ano ba value ng A. Familiar kay A. So, si A, ang tawag natin kay A, that is a unit vector. So that is the A operator kung tawagin yan sa polyphase. At ang value palagi ng A unit vector, kapag sinabi natin unit vector, ang magnitude is 1. Pero ang angle niya, that is what? 120. Yan si A. Kaya kapag kinuha natin si A squared, kung babalikan mo ang yung complex number, this should be 1 squared quantity 120 multiplied kanino? 2. So this is simply 1 bar angle of 240, or this is also the same as 1 bar angle of negative 120. Yun ang value ng ating A squared. So usually, ginagamit natin ito sa mga balance, no? Kaya nga symmetrical. Pag sinabi symmetrical, balance. Okay? Para ma-express na lang natin ang value in terms of A. Kasi si A, unit vector, ang magnitude is only 1. Tapos yung angle, ang importante sa kanya, yung kanyang angle. 120 and negative 120. Ano yung nahanap kay number 25? So, what would be the value of 1 plus A plus 1? A squared. So, kapag kinumpute mo yan, this is only 1 plus 1 bar angle of 120. Tapos, i-add mo lang si 1 bar angle of negative 120. So, pwede mong diretsuhin yan kay calculus. ibibigay ni Calcu yan, that is directly 0. Okay. Nakuha ba kapatid? Kasi nire-represent itong 1, that is your AN, your A squared, that is your BN, and your A, that is your CN. So kung balance yan, pag inad mo yung unbalanced current, so kung balance yan, the total value should always what? 0. So ito rin yun. No? In-express lang in terms of A operator. A is a unit vector. Okay? So yung 23, 24, at 25, so same formula dito sa ating wattmeter. Ito lang yun. No? Dalawang pwede nyo gamitin na formula in dealing with 2 wattmeter. Ito yung isa. Kung walang given na voltage, pwede nyo puntahan ito. Lalabas diyan 2 equations to unknown. Applicable ito pag walang voltage at saka unbalanced yung load. Makukuha mo ng sabay yung reading ni wattmeter A, wattmeter B. Ang gagamitin nyo rito, lalabas dyan is 2 equations to unknown. Gagamitin mo mode 5-1. Okay? So ngayon, kung meron namang line voltage, okay, kung may line voltage, so pwede nyo gamitin ito. Yun nga lang, take note, that is only for balanced load. Okay, kuha. So, dalawang formula, ito, at saka yan, for 2 wattmeter methods. Okay? So, any more question regarding wattmeter, kapatid? Tanong ba? Any questions, kapatid? Pwede ko nang iwanan yung wattmeter. Okay na tayo kay wattmeter. So, iwanan ko na si wattmeter. So, let us discuss now yung ating next topic. So, dun tayo sa electrical transient, ano? Or simply transient. Ko lang okay, so let us discuss no, yung ating transient or simply electrical transient. Kumbaga, sa circuits, dati kasi, ang circuits 4. Pero ngayon, mga latest na curriculum, 3 na lang naging circuits. Sa K-12 pa nga yata, kung pasok na kayo sa K-12, so ang circuits, 2 na lang. No? Circuits 1, circuits 2, pinag-combine. Yun, 2, di ba? So, 2 na lang ang naging circuits ninyo. So, yun ang medyo masaklap kay K-12. Medyo compressed yung mga major subjects. Unlike sa amin dati, 4. So, circuits 1, 2, 3, and 4. Circuits 1 is DC. Circuits 2 is single phase. Circuits 3 is polyphase. Circuits 4 is ito yun, electrical transient. Okay? So, although, so circuits pa rin ito, kaya lang, more on calculus ang approach, differential equation at saka Laplace transform ang solution, kumbaga sa control system. Pag sinabi kasi natin electrical transient or simply transient, di ba pag sinabing transient, panandalian lang. No? So electrical transient always represent to the circuit phenomenon at which the given circuit changes its condition, no? A sudden change in the state of the given circuit or condition of the given circuit due to what? Energy is stored in the given parameters. No? A sudden change in the state of the circuit or condition of the circuit due to energy stored in a given circuit. Ano ba yung energy stored na yan? Kung babalikan natin, yung ating electrical parameters that is mainly divided sa 3 or mainly characterized by our resistance, inductance, and capacitance. Alam natin, doon sa 3 circuit parameters na yon, si inductance and capacitance, yun lang yung merong kakayahan. No? So those are only the circuit parameters that has the capable to store energy. In inductance can store energy in a form of what? Magnetic field. Yung ating capacitance can store energy in a form of electrostatic field. So therefore, every time that the given circuit contain inductance or capacitance, also basically we may always encounter this given electrical transient o yung sudden changes in the state of the circuit due to energy of that particular parameters. Okay? Kaya nga kung papansinin mo, kung meron pa tayo dyan na, ang tawag dito, meron pa tayong fluorescent lamp, pag inon mo si fluorescent lamp, hindi siya ganun agad super light, di ba? So, unti-unti, mag-i-increase mo na yung kanyang pagkaka-light, no? Hindi siya agad totally 100% lighted. So, unti-unti, mag-i-increase mo na. Ganon din naman yung ating dating charger. Kung meron kang charger na meron pa siyang indicator, o yung LED indicator, pagkabunot mo sa charger, no, pagka-unplug mo, so hindi naman agad naka-off yung LED indicator, di ba? Meron pa rin niyang ilaw, unti-unti, magdi-discharge siya. So, ganun din yung ating mga electronic gadgets, so mga television, kung meron pang LED indicator sa kanilang power, kahit in-off mo na yan, in-unplug mo na, so hindi pa rin siya agad totally shut down kasi nandun pa rin yung energy stored in the given circuit. Kailangan mo nang ma-discharge yun before siya ma-fully shut down, no? By means of resistance. So, yun yung transient. No? So, the sudden change in the state of the given circuit due to energy stored in the given circuit's parameter. So, in that case, meron tayong tinatawag na single energy transient. Pag sinabi nating single energy transient, so for single energy transient, ibig sabihin, isa lang sa available circuit parameters ang may kakayahang mag-start ng energy. So, ibig sabihin, sa circuit, pag tinignan mo, nandun lang si inductor. So, pwede may kasama siyang resistance. Kumbaga, meron ka lang RL circuit or RC circuit, no? For single energy transient. For single energy transient, pwede mo ma-encounter you have resistor and inductor or resistor at saka capacitor. So, hindi pwede magsama yung inductance at capacitance doon sa tinatawag nating single energy transient. Then, kung may single, meron din tayong double energy transient. So, pag double energy, ibig sabihin, we have now two parameters available that has the capable to store energy. So, pwede natin ma-encounter dyan yung ating RLC. Para bumalik lang tayo kay RL, analysis lang ng ating RL at RC at RLC doon sa tinatawag natin transition period or transient current. So, balikan natin yung iba pang topic under transient as we try to solve this given problem. So, number one, meron tayong coil. So, take note, pag sinabing coil, alam natin, unless otherwise, coil represent by what? Series, resistor, and inductor. Kasi doon sa coil yan, that is a wire. No? So, papaikutin natin, gagawin natin siya parang spring. Eh, may resistance yung wire na yun, so that would be R. Eh, pag ginawa natin siyang spring o yung coil, so inductance yun. Kaya pag sinabing coil, unless otherwise, that is series RL. So a coil has 2,500 turns and the current of 10 ampere. Flowing in it produces an effective flux of 0.06. However, if the resistance is 12 ohms, what is the time constant? Sino yung time constant na yan? So puntahan natin yung single energy transient. So let us consider for single energy transient, meron tayong RL circuit. For RL circuit, let us just consider its initial state is naka-off position, then i-energize natin. So, dati siyang de-energize, tas energize, or dati siyang naka-shutdown, then i-on natin. So, balikan lang natin yung simple circuit. Okay, so let us consider, no? From initially the circuit is in off, so naka-open yung ating switch. So this would be our switch. So therefore, at time equal to 0, so papasok yung arrow. So ibig sabihin, close natin yan. So the moment that the switch is closed, so we have closed circuit, so apply tayo ng KBL. So pag nag-apply ka ng KBL dyan, lalabas that the voltage drop across R plus the voltage drop across L, it should be equal to the source voltage E. However, pag kinuha natin yung ating current o yung ating voltage drop across R, that is the product of our resistor by Ohm's law at saka yung ating circulating current. And the value of voltage drop across L, alam na natin from our DC circuits, it is always LDI over DE. And the given source voltage, that is E. So that would be our KBL equation in a given circuit. So this equation, gagamitin natin yan to determine what would be the possible value of current. No? So alam natin yung current dito, pagka-switch natin, hindi naman siya agad maximum value or steady state value. So ano muna mangyari dyan? So unti-unti, tataas yan until it reach yung tinatawag natin steady state or ang tawag natin sa steady state. So, pag sinabi natin steady state, so wala nang changes to sa kanyang current. Ibig sabihin, pagka kinuha natin, pinlat natin yung behavior ng ating current in this RL circuit, dati siyang naka-off position, then i-on natin. So, kapag kinuha natin yung behavior ng ating current, with respect to time, kung gaano siya katagal connected sa circuit, so horizontal is the time and the vertical axis is the current. So obviously, ang makikita natin dyan, so the current continually increases then until it reaches the final steady state. Kaya nga kung babalikan nyo doon sa inyong control system, so yung ating total response of the given circuit, it is composed of two, no? Forced and natural response o yung tinatawag nating transient response and the steady state response. So during this given time, tawag natin is transient response, the current continually increases. Then when the current reaches its maximum highest possible value, so doon na siya mag-i-steady, doon na siya mag-i-stay ang value. Constant na siya doon. So ang tawag natin dito, it is already a steady state value. So therefore, para makuha natin what would be the possible equation of this given current, kailangan nating isolve itong differential equation na to. So since tapos na kayo ng DE, ng mathematics, hindi ko na ito isosolve manually. Kapag sinolve niyo ito, ang gagamitin niyo na lang, ilalagay ko kung anong gagamitin niyo, that is under your full DE o yung first order linear differential equation. Ano yung kanyang standard form? Kung babalikan nyo, yung dy over dx plus y p of x equal to q sub x. Yan ang magiging standard equation ng ating full DE at yan ang gagamitin natin para masolve nyo yung equation or yung particular solution ng ating current in this given circuit. So dito, pwede natin i-compare na yung value ng y represent the current and the value of x represent the time elapsed. Kung gano'n na ba katagal connected yung ating circuit doon sa kanyang source. So that will be the value of x that represents time. So dito, kakailanganin natin ng initial value. Anong initial value? So based on our plotting, no, at time equal to 0, current is what? 0. Yun palagi ang initial value. Sir, bakit at time equal to 0, current is 0? So tatandaan natin, at time equal to 0, ito yung important terms na kailangan natin balikan. Yung behavior ng ating parameters. Diodes. Ano yung ibig sabihin ng diodes? So at DC, at time equal to 0 from off i-on natin connected to DC source, your inductor behaves as virtually open, your capacitor is shorted. No? At DC, at time equal to 0, inductor is open, capacitor is shorted. So, ibig sabihin, nung inon natin ito, ang behavior ng inductor natin, mag-start na siyang mag-fully charge, so naka-open siya, virtually open. So, alam natin, pag open yan, the resistance is what? Approaches to infinity. kaya yung ating current doon is still zero. So ngayon, habang tumatagal kapatid, so na-charge yung ating inductance, so unti-unti naman, as time increases, or sabihin natin, as the moment time approaches to infinity, yung behavior naman yan, hindi na siya diox, instead, disco. Ano ibig sabihin ng disco? At time it approaches to infinity, so ibig sabihin, matagal nang connected ito sa ating circuit at DC source. Yung at DC source, inductor now is shorted, capacitor is open. Kaya nga pagdating doon sa ating DC, yung ating inductance, anong ginagawa? Sinushort lang. Sir, bakit sinushort na lang? Bakit siya shorted? Kasi alam natin, at time approaches to infinity, nandito na tayo sa tinatawag na steady state. So pag sinabi nating steady from the term itself, may changes pa ba yung current? Wala na, kaya nga steady state, di ba? So kung steady na yung value ng current, your DI over DT, it is already what? Zero. Wala nang changes sa current pagdating sa steady state. Kailan lalabas steady state? As time approaches to infinity. Ibig sabihin, matagal nang connected yung ating RL circuit do sa ating source. Kaya ano na to? Zero. So kung zero yan, so value wala, para na lang siyang shorted. Kaya ang magiging voltage drop across R equal kanina E. So yun yung ating kailangan i-recall pagdating siya sa transient analysis. At time equal to zero, diox. At time equal to infinity, disco. So therefore, pag sinolve mo ito kapatid, you may have the value of current, no? At time equal to zero, the current in RL circuit is zero, but at time equal to infinity, the value of your current represent the steady state or the maximum value, which is simply equal kanina, E over R. So yan yung ating magiging initial value in dealing with RL to solve for the particular solution. So hindi ko na ito isa-solve using Paul DE, ano kapatid? Ibibigay ko na lang. So in the particular solution of this given current, it would be equal to maximum value of current, 1 minus e raised to negative t, i-divide natin kanina, lambda. So that would be the value of current in this RL circuit from off position to on position at any given time. Kaya habang patagal ng patagal, as time approaches to infinity, e raised to negative infinity is 0, ano matitira? Maximum value of current. Okay? So, ano value ng lambda? This lambda, it is known to be the time constant or TC. So, for RL circuit, iba-iba time constant, depende kung anong parameters meron. Sa RL circuit, the time constant, that is what? L over R. Sir, ano po importance ng time constant na yan? So tulad dito, do sa ating condition, dating off, i-on natin. So time constant, that is the required time. Simula nung i-on natin yung switch, that will be the required time for the circuit to become activated or fully operational. Kumbaga, that would be in terms of value, that is the required time at which the current reached up to 63.6% of its maximum value. So at 63.6%, so that is the minimum amount of current at which the circuit is fully operational. Nakuha ba? Ito yung pagka-on mo doon sa ating circuit, no? Doon sa pagka-on mo doon sa ating fluorescent lamp, ito yung time na yung ating fluorescent bulb, papitik-pitik pa ng ilaw, no? Hindi pa siya totally naka-steady. So papitik-pitik pa lang yan. So pagdating niyan doon sa steady state, so ayun na, 'di ba? Hindi na kumikislap yung ating fluorescent lamp. So that is the time constant. That is the minimum time required for the given circuit, RL circuit, to be fully operational or to start operate normally. And for RL circuit, it is the ratio of its inductance and resistance. So therefore, pag alam mo na yung value ng current, so wala nang problema kapag hinanap sa iyo yung voltage across R at saka voltage drop across L. Sir, ano yung disco? So yung disco at DC, ito yung behavior ng ating inductor at capacitor. Kasi si inductor at capacitor, yun yung ating consideration kay transient. Kasi sila lang yung may kakayahan makapag-start ng energy. Kaya kailangan natin balikan ano yung kanilang standard behavior with respect to DC source. So at time approaches to infinity, kapag matagal nang connected yung ating circuit or matagal nang naka-close yung ating switch, at DC source, inductor shorted. Capacitor, open. Ha? Yan ang disco. Kabaligtaran lang. Yung O, open. Yung S, shorted. Yung I, inductor. Yung C, capacitor. Okay po ha? Gets mga kapatid? So yun lang siya ha? So natandaan natin yung diox at saka diode or disco. So therefore, pag alam mo na yung value ng current, mabilis na lang yan. Pag sinolve mo ngayon yung B sub R, ano formula ng B sub R? R times I. Ano si I sub M? E over R. Kaya kapag sinubstitute mo dito, lalabas at any given time, the voltage drop across resistance in series with inductance, it is the source voltage E quantity 1 minus e raised to negative t over lambda volts. Therefore, pag kinuha mo ngayon yung voltage across L, pwede mong i-differentiate ito, then multiply by L or by Ohm's law or by KVL. Alam natin yung source voltage, alam na natin ngayon ito. So B sub L is E minus B sub R. So therefore, the value would be source voltage constant E raised to negative T over lambda volts. Kaya kung papasinin mo, ang value ng voltage drop across L as time approaches to infinity, unti-unti nagsisira siya. Okay? So for RL circuit, from off position to on position, ito na yung mga formula na kailangan nating balikan. So pag alam mo na yung formula, direct substitution na lang yan. Mabilisan na lang. Ngayon, pag nakalimutan mo itong formula na to, simple lang, babalik ka kay calculus, differential equation, ang gagamitin mo. Kung ayaw mong gumamit ng differential equation, you may use Laplace transform. Kailangan lang, alam mo, itong mga initial values ng ating circuit. Kasi itong mga initial value na to, hindi yan binibigay ng problem. It is always understood na alam natin ang behavior ng inductor at capacitor when connected to your DC source. That is at time equal to 0 and at time approaches to infinity. Nakuha ba? So therefore, dito sa ating problem number 1, let us consider ito yung ating coil. Okay? That represent by series RL. Number of turns N equal kanino? 2,500. Okay, then at time equal to 0, switch is closed. So you have the resistance of the circuit that is only 12 ohms. So nainanap, let us consider at time 0, switch is closed, current is 1, 0. But let us consider as time approaches to infinity, we have found out that the given current is already 12 ampere. So alam natin from our DC, once the given coil is energized, magbibigay yan ng ano? It would provide the necessary flux. So gaano kalaking flux or magnetic field ang kanyang na-provide? 0.06 Weber. So hinahanap, for this given coil, what would be the corresponding time constant? So time constant, lambda, for RL, that is L over R. Okay? So yan ay ating equation. So meron na tayong R. Kakailanganin na lang natin sino? Si L. Okay? Naalala pa ba yung ating DC circuits, how to determine the self-inductance? Anong formula nga natin, kapatid? Naalala pa ba? Doon sa ating DC circuit, self-inductance, sino ang kailangan nating i-recall na pangalan? Naalala ba? Yung ating first topic, self-inductance. Anong formula ng self-inductance? Paano kunin ang inductance ng isang coil? Naalala pa ba yung formula? Anong pangalan yon, kapatid? Still recall? Sino siya? Doon sa ating first meeting, doon sa DC circuits natin, naalala ba ba? How to solve for the self-inductance. Sino yon? Anong pangalan? Naalala? That is under Lino. Naalala si Lino? So, inductance times the current equal to number of turns of that coil and the corresponding flux. So, at time approaches to infinity, current is 12. So, this would be the maximum value of current required to provide the corresponding amount of flux of 0.06. So therefore, using this formula, alam na natin that inductance is the number of turns flux over the corresponding current. So yun na ipasok natin dito sa ating equation para isang compute na. So makukuha na natin yung ating time constant. So time constant for this given circuit equal to number of turns. Sir, paano nakuha yung 12 ampere ba? Ba't 12 ampere ang nakalagay? 10 ampere lang yan, kapatid. Ang 12 is the resistance. 12 ang nakita ko. 10 ampere lang yan, kapatid. Mali yung marker. 10 ampere yan. Mali na sulat ng marker. Okay? So, wala nang problema. Ano si L? Number of turns, 2,500. The flux provide 0.06 over the current, 10 ampere, divide natin kanina, 12. Ayan na ang value. So, 25 times 0.06 divided by 10 over the resistance of 12. So, you have 1.25. Ano palagi ang unit ng time constant? It is measured in terms of time, kaya seconds. Okay, go ha? Any question regarding problem number 1? Huh? So, itong formula ng lambda time constant, so na-derive yan kapag nasinod mo itong differential equation. Pag-practicean mo doon sa iyong DE, Paul DE ang gagamitin. Naalala ko ba? So, kay Paul DE, pag kinuha mo yung general solution ng Paul DE, that is the variable y multiplied kay integrating factor, integral of q sub x, integrating factor, dx, at saka mag-add ng c. Ano itong variable p na to? Ito yung tinatawag nilang integrating factor, which is e raised to integral of p of x dx. So, dyan mo makukuha yung ating equation ng time constant. Pag sinolve mo itong differential equation na to, so take note, yung y is the I, yung t is the corresponding x. Makukuha yan. So, ito na yung formula. Yun nga lang, take note, this formula is applicable kaninong circuit? RL circuit, at anong condition? From off position, i-on natin. So, ang tawag natin dyan, classification of transient, this is the initiation transient. Initiation. Tama ba spelling ng initiation? Tama. Transient. That is from off to on position. So, ibig sabihin, from the term initial values. Okay? So, increasing yung value or yung behavior ng ating total response. Okay, nakuha ba? Any question regarding problem number 1? So, iwan ko si number 1. Let us try number 2. For number 2, again, we have a coil has time constant of 1 second. So, yung ating coil, eto na rin siya, no? So, i-copy ko na lang. So, we have RL circuit that is from off position to on position. So, binigay na that the coil has a time constant. Sino yung ating time constant? Lambda, which is the ratio of L over resistance, according to problem. A coil has a time constant of 1 second. Then, inductance of 8 Henry. And connected to our source voltage, which is 100 volts. DC source. So, determine the rate, rate speed, kung gaano ba kabilis mag-increase, no? Determine the speed at which the current increases. No? Rate of rise is the increase of the current. Rate is the speed. Gaano ba kabilis mag-increase yung ating current. Okay? So, hinahanap lang dyan, what would be the speed at which the current increases, di over dt. Kailan natin kukunin yan? at time equal to 0. So, gaano ba kabilis mag-increase yung current at the instant that the switch is closed? So, kung babalikan natin kanina ulit from our corresponding KBL, lumalabas that the value of voltage drop across R plus voltage drop across inductor, that is equal to R times R plus LDI over dt equal to E. Hinahanap natin, ayun, no? DI over dt. So, balikan natin at time equal to 0. Alam natin, at time equal to 0, ano ang behavior natin? The behavior that inductor at DC, inductor is open, capacitor is what? Shorted. So, ibig sabihin, dyan sa ating circuit, at time equal to 0, virtually open yung ating inductance. Virtually open. So therefore, at time equal to 0, kapag sinukat natin yung voltage drop dyan, yan ang magiging value ni B sub L. Kasi dyan yung ating inductance. At time equal to 0, open yan, current is 0. So pag nag-tap tayo ng voltmeter dyan, sino nasukat mo? Tama ba? Dahil naka-open ito, so baliwala sino? Current. Current nga is 0. Ano voltage drop across R at time equal to 0? So this is 0. So lumalabas, this value is simply what? E. Nakuha? Since at time equal to 0, inductor is open, current is 0, so pwede rin sabihin, this is simply what? 0. Kaya yung voltage drop across L, that is simply E. Ito yun. Diba? Ito si BL equal to E. So therefore, kita na natin that the value of your DI over dt, it is always equal kanino? E over L, which is only true at time equal to 0. Nakuha ba? So therefore, the final answer, meron ka lang 100, i-divide mo ng inductance, that is 8. So the current increases by 12.5, tama ba, no? 100 over 8. So tama lang. The current increases by 12.5 ampere per second. So yun yung hinahanap ng ating problem. Ganyan kabilis mag-increase yung ating current. Anong letter? So this should be cast time. Okay, kuha ba? Any question regarding problem number 2? So tandaan na natin ito sa RL circuit at time equal to 0 para hindi ka na lang mag-derivative. Ito na siya, E over L. Sir, paano kung hindi siya time equal to 0? Let's say, sir, hinanap sa amin, gaano kabilis mag-increase yung current at time equal to, sabihin natin 1 second simula nung i-close siya. So, this is at T equal to 1 seconds. So, paano po namin siya isosolve? Simple lang. Alam na natin yung equation ng current. Ito si current. Tama ba? So, kung di over dt, you take the derivative of this one. I-differentiate mo to, anong limit? Kung ano yung given value of t. Ganun din naman ito. Pag dinifferentiate mo to at time equal to 0, ano lalabas? Tingnan natin, ano? Substitute natin. Ano si I sub m? Di ba? I sub m is E over R. Okay. Ano yung ating E? 100 volts. Ano yung time constant? 1. Di ba ang time constant natin is L over R. So kung 1 ito, ano resistance ng circuit? So this resistance is also 1, 8 ohms. Tama ba? Since ang time constant is simply 1. Kaya kung hindi mo nakita yung analysis na yun, DI over dt, so pwede mong i-differentiate ito. So pwede natin puntahan yung derivative functions ng calculator mo. Ayun. Ano maximum value of current? Ano source voltage? 100 over kanino? 8. So i-times na lang natin kanino? 1 minus shift E of negative, so alpha x, that is the time. Time constant natin, 1 lang naman. Diba? Kailan natin kinukuha? At time equal to 0. So, gawin ko to 0. No? That is the limit. So, equal mo, ayun din, 12.5. Kaya in case, hindi hinahanap is a time equal to 0, let's say hinanap sa iyo, at time equal to 1 second, simula nung i-close yung switch. So, ito lang babaguhin mo doon. Kung ano binigay na time, yun ang magiging limits mo. Let's say, after 1 seconds, ano value niya? 4.59 na. Ganon kabilis. Ampere per second. So and then, so forth. Nakuha ba, kapatid? Any question regarding problem number 2? So, iwan ko, no? Let us try number 3. So for number 3, a constant voltage is applied to RL circuit at time equal to 0. Okay, so ulit, yung ating circuit, i-copy ko na lang dito. We have RL circuit. At time equal to 0, the voltage across the inductance, at time equal to 0, voltage is applied to a circuit. Hindi binigay kung anong source voltage. So, at time equal to 0, switch is closed. So, nagpalipas tayo ng certain period of time. Let us consider at least of 1, no? Simula nung i-close natin yung switch, palipas tayo ng how many seconds? So, based sa problem, 3.46 milliseconds. Sinukat natin yung voltage across inductance, BL1. Anong napansin natin? This is 20 volts. So, again, pinalipas pa natin. So, palipas pa tayo ng certain period of time. So, after a total time elapsed, simula nung i-close yung switch, sabihin natin 25 milliseconds. So, after 25 milliseconds, kinuha ulit natin yung voltage across inductance and we have found out that this case, it is now only 5 volts. So, if the inductance of this given circuit is 2 Henry, what is the value of R? So, hinahanap naman natin ano value ng R. So, saan natin makakuha yung value ng R? So, kapag alam na natin yung time constant, so since no, yung ating time constant is L over R, required resistance. Saan natin makakuha yan? Alam natin, time constant, it is just simply L over R. So in that case, our possible solution to solve for R, that is simply whatever the inductance, i-divide natin kanino, time constant. So ang aim natin, mahanap yung time constant na lambda. Saan natin kukunin yan? So we have the voltage across inductance. So kung babalikan natin kanina, that the voltage drop across inductance, that is simply equal to E, source voltage, E raised to negative T over lambda. So using this equation, i-substitute natin yung dalawang value, no? BL2, T sub 2. BL1, T sub 1. So substituting the given data, so sabihin natin this is BL sub 2 equal to source voltage, constant E, raised to negative, sino to? T sub 2 over lambda. Ganun din, BL1, it should be equal kanino? E, E raised to negative, sino dapat to? T sub 1 over lambda. So, ibaba ko lang ng konti. Okay, so anong gagawin natin dyan? So, gamitan na lang natin ng algebra. Let us just divide the two equation. Yeah. So, pag dinivide natin yan, same circuit, so same yung voltage, cancelled out. So, apply na lang natin by law of exponent, dividing same base, ano gagawin? Subtract the exponent. So, ito, isusubtract ko sa taas. Minus negative T1, negative, magiging positive. So, ito yung simplified value nila. So, this is BL2 over BL1 equal, copy the base, E raised to, ilabas ko na lang sino? Yung aking 1 over lambda. So, ito, negative T1, tataas, negative, so positive. So, magkakaroon tayo ng T1 minus what? T sub 2. Gets ba? So, therefore, para matanggal si E at masolve na natin si lambda, gagamit ka na lang ng loan. So, in that case, lambda, it is always equal kanina T1 minus T sub 2, i-divide natin kanino? Ln of dl sub 2 over dl sub 1. So, yan ang formula ng ating lambda given to specific value of voltage with respect to or voltage drop across the inductance. So, lahat given na. So, pwede na natin diretsuhin. So, solving for lambda, it should be equal to, ano si T sub 1? 3.46 milliseconds, so 0.00346. Minus T sub 2, 25 milli, 0.025. Ln, BL2 is 5, BL1 is 20. So, kuha natin yung time constant. Malubas, kaya check, no? 0.00346 minus 0.025 divided by ln of 5 over 20. So, meron tayong 0.01553 seconds. Therefore, resistance is inductance. Ano inductance? 2 over this given time constant. So, 2 over the answer, meron tayong resistance at gilid. 128.72 ohms. That should be the answer. 128.7 will do. Anong letter yan? This should be dog style. Gets ba? Nakuha kapatid. Kasi transient, panandalian lang. No? Mabilis lang yan. Direct substitution doon sa ating mga derived formula. Yun nga lang, dapat kakilala mo yung formula. Kasi pag nakalimutan mo yung formula, anong derivation? Differential equation. Okay? Kaya calculus ang approach ng ating transient. Pag nakalimutan mo yung formula. Pero kung kabisado mo na yung formula, algebra na lang. Direct substitution. Okay. Kuha ba? Any question regarding problem number 3? So number 4. A series RL circuit with resistance of 50 and 10 Henry has a constant DC applied at time equal to 0. Find the time at which the voltage drop across R and L is equal. So RL ulit tayo, ano? Number 4. So, at time equal to 0, switch is closed. So, hindi lang binigay ulit kung ano yung ating source voltage. But based sa problem, resistance of this given RL circuit is 50 ohms and inductance of 10 Henry. So, using that data, you may consider that time constant L over R 1 over 5. So, that is what? 0.2 seconds. So, let's say, switch is closed. Ano ang hinahanap, kapatid? How long would it take? So, sabihin natin, T sub 1. Simula nung i-close natin yung switch. At which, the voltage across L is equal to the voltage drop across R. Okay? So, gano'ng katagal bago yung voltage drop between these two parameters become equal? Eh, alam naman natin at all cases, by KBL, B sub R plus B sub L is always equal kanino? Source voltage. So therefore, palitan ko na lang B sub R as B sub L. So ito, substitute ko dyan. Anong makikita natin? That twice of B sub L is equal to the source voltage. Eh, ano ba yung equation ng ating B sub L? So, what would be the equation ng ating B sub L, kapatid? No. Wait lang. Okay? So, alam na natin kanina, na-derive na natin that P sub L, it is always equal kanina. You have your E negative T over lambda. Okay? So, in that case, masasolve na natin yung ating value of time constant o yung ating T sub 1, no? Twice of B sub L, that will be our source voltage. Okay? So, B sub L, so pwede natin, oops, hindi pala dapat dyan yan naka-equal. Hindi tayo maligaw. Dapat pala ito ibababa ko rito para hindi kayo maligaw. Baka naka-equal lang. Yan yung equation ng ating B sub L. Yun. Tapos anong gagawin natin? Ito, ipapasok natin doon. So pagkapasok dyan, ano magiging equation natin? After we substitute, ito na, that twice of the source voltage E raised to negative E over lambda, that is our B sub L, equal to our source E. So pwede ko nang i-cancel ito. We may cancel source voltage. So by algebra, kuha na natin yung value na T. So lumalabas, the value of T, which is equal to T sub 1, it should be equal to negative lambda load of what? You have B sub L, i-divide na lang natin. Na lang, no? So you have E over kanino? B sub L1. Ayun ay ating magiging equation dyan. Okay? So wala nang problema. Your BL1, that is 2BL, kaya ano natira, no? Cancel itong E, bababa 1 half. So therefore, T sub 1, it is equal to negative. Ano yung lambda? Nakuha natin 0.2. Loan, ano source voltage? E, BL is twice of B sub L. Kaya ano tira? This is simply 1 half. So we have now the final answer. So negative 0.2 times load of 0.5. So that would be the required time at which the voltage between these two parameters become equal. So you have 0.1386 seconds. That should be the answer. 0.13, ayun, anong letter yan? That should be cut style. Gets ba? Nakuha? Any question regarding problem number 4? So again, RL pa lang tayo, kapatid. Na kay RL pa lang. So dapat kabisado natin yung behavior ng ating RL pagdating dyan sa DC source. So yung ko si number 4. Let us try number 5. A circuit whose resistance is 20, inductance of 10, steady state voltage of 100 volt is suddenly applied to it. So, from on to on, or from off to on, for the instant of 0.5 seconds after the voltage is applied, determine the total power input in the given circuit. So, for problem number 5, uy, bakit ganyan na siya? So, binago lang yung ating data. So, the resistance of the circuit, that is 20, and this is still 10 ohms. So, using this data, lambda, that is simply 0.5 seconds, no? L over R. Suddenly connected to our source voltage of 100 volts. So, ano hinahanap? Required. What would be now the given power supplied to the circuit? Sabi ko na lang P sub 1 at T sub 1 is equal to 0.5 seconds. So what would be now the real power consumed by this resistance? No, alam natin, resistance, that is only the component that consumes real power. What would be now the power absorbed by this resistance after 0.05 seconds? No? After 0.05. So by power formula, alam naman natin, power, it is just simply in terms of current, whatever the current is squared mo, multiplied kanino? Resistance. Diba? So, kailangan natin ngayon kunin ano yung value ng ating current at T is equal to 0.5 seconds. So, therefore, alam na natin that the current here, it is equal to whatever the maximum value of current quantity, 1 minus e raised to negative t over lambda. Okay, so makukuha natin yung ating corresponding current, then squared na lang natin, multiplied by R, we have now the power. So solving for the current na. Ano maximum value of current? That is source voltage over the resistance 20 times 1 minus e raised to negative. Ano yung time na hinahanap natin? 0.5. Lambda, nakukuha natin, that is also 0.5. So we have the current in the circuit after 0.5 seconds. Ano lumabas? So you have 5 times 1 minus shift e of negative 1 na lang. No? So this would be the current. 3.16 ampere. Therefore, power, it would be 3.16 squared multiplied kanina 20. So, squared ko na lang times 20. So, meron na tayong sagot. 3.16. Total power supplied pala, no? Na-close. So, hinahanap input, total input power. So, input power pa lang hinahanap, kapatid, not the power. So, pag sinabi natin input power, so pag power, alam natin, that is the product of voltage, no? Total voltage, and the corresponding current. So, this current represent the current after 0.5 seconds. So, that is I. So, therefore, yun ang gamitin natin equation dyan. So, 3.16 ampere multiplied the source voltage of 100 times kanina 3.16. So, this would be the input power or the total power supplied by our circuit. So, ilan yan? So, this should be 316 watts. That should be the answer. Yung 199, that is only the power absorbed by this resistance. So that is only the power across the resistance. So that is 199. So 199 point something, 200 watts. Kaya lang hinahanap natin is the total input power. So pag input, that is the power supplied by our source voltage E. So therefore, that is the total voltage multiplied kanina, whatever the supplied current in the given circuit. Kumbaga, that is the instantaneous value of our power at time equal to 0.5 seconds. Diba ba? Any question regarding problem number 5? May tanong ba kay problem number 5? So, iwan ko si problem number 5. Let us try number 6. So, number 6, the armature of a relay working on a 200-volt circuit operates when the current reaches 0.24 ampere. It is required that the relay shall close 0.004 second after the relay circuit is closed. Nadoble yata, no? It is required that the relay shall close 0.004 seconds after, okay, tama, no? 0.004 second after the relay circuit is closed. And this time is corresponds to the time constant of the circuit. What is the inductance of the relay circuit? So, kumbaga, gumamit tayo ng simple motor control, no, to start a given motor. So, kung draw natin yung kanyang ladder diagram, So let's say the source voltage is 200 volts and this is our 0 volts. So we have the switch, then connected dyan yung ating relay circuit, relay R. So si relay, when activated, ang kanyang i-command yung ating contactor. That is normally open, and this contactor, that is, sabihin na lang natin, in series with our motor. So kapag energized na yung ating relay, so this contactor R will close. So pag na-energize na yung ating relay, magko-close na yung ating contactor. So therefore, meron na tayong source do sa ating motor. So start na yung ating motor. So anong binanggit na problem? In order for this given relay circuit, no? So para mag-activate itong ating circuit na yan, so simula no at time equal to 0, switch is closed, huwag na tayo maglagay ng latching. So pag on or pag push natin itong button, ating switch, so on yan. So therefore, para ma-activate muna yung ating relay circuit, ma-energize itong ating relay, dapat daw ang current dito, it should be equal na kanino, 0.24 ampere. Okay? So dapat pag on natin dyan, alam naman natin, pagka-on mo dyan, hindi naman agad na 0.24 ampere. So kaka-on mo pa lang, so 0 pa yung ating current. So unti-unti increases. So based sa problem, this given relay will be activated if the current passing through its coil, it is already 0.24 ampere. So binanggit ng problem, 0.24 of ampere will pass in the given relay or coil of the relay. That is at time equal kanino? 0.004 seconds. So simula nung i-close natin yan, at time equal to 0, switch is closed. So current continually increases. Then it reaches 0.24 ampere at a given time of 0.004 second time elapsed simula nung i-close natin yung switch. So at 0.24 activated yung ating relay. So signalin niya na itong ating contactor. So magko-close na yan. So mag-on na yung ating motor. So based sa problem, this given 0.004 second represent also the time constant for this relay coil. No? So si relay, pag biniksan na natin yan, ang kanyang main component, that is again a coil. So pagka-coil yan, lumalabas yung ating relay circuit. Pag kinuha natin yung equivalent circuit niyan, para lang tayo ulit merong RL circuit. So ano hinahanap ng problem? What would be the corresponding inductance of our relay? Okay? So pag kinuha natin yung kanyang relay circuit, so source voltage natin dito, this is 200 volts. So hindi natin alam kung ano resistance at wala ring inductance. Hindi given. So based sa problem, so that in order for this relay to be activate and send signal to the contactor para mag-close yan, so based sa problem, after 0.004 seconds, the current should be what? 0.24 ampere. So what would be the inductance? So saan natin kukunin yung ating inductance? L. Okay? So to solve for the inductance, walang flux na given, walang number of turns doon sa coil ng ating relay. So saan natin kukunin? Doon sa kanyang time constant. Alam na kasi natin si time constant which is also 0.004. So this is L over R. So ibig sabihin, using the value of your time constant, solving for L, that is only the product of your resistance and the time constant. So saan natin ngayon kukunin yung ating resistance? So alam na natin that the equation of current, it is equal to maximum value quantity 1 minus e raised to negative t over lambda. Eh, alam na natin kapatid that this maximum value is source voltage over the resistance. So, pwede natin ngayon ipag-cross multiply dito. Okay? So, cross multiplying, pwede natin sabihin that resistance of the given relay circuit, it should be equal to source voltage over the corresponding current I after 0.004 seconds. Quantity 1 minus e raised to negative t over lambda. So substituting the value, this is 200. Anong required current for this relay to activate? 0.24. 1 minus e raised. Anong required t sub 1? So that is 0.004. Ano lambda, which is also 0.004. So pwede ko na lang diretso yun. This is e raised to negative 1. So we have now the corresponding resistance. So this would be the resistance of our circuit, 200 over the required current times the quantity 1 minus shift e of negative 1 na lang. So meron ka ng resistance of the coil, 526.78 ohms. Therefore, inductance, that is just the product of resistance and time constant. I-times ko na lang ito ng 0.004. Meron tayong inductance. So the inductance should be 2.11. Ano unit niya? It should be in Henry. Meron ba? 2.1. Pwede na. Anong letter? So it should be arriba. Okay. Nakuha ba? Any question regarding problem number 6? So you have 2.1 Henry or 2.11. Nakuha ba? Any question regarding problem number 6? Okay tayo doon? Gets natin? So, iwanan ko si number 6.
Yes, sir. Hello, sir.
Yes.
Sorry, sir. Paano nga naging negative 1 yung negative t over lambda, sir?
Negative 1 since the time required for the current to reach 0.24 ampere is 0.004. And based on problem, that corresponding time, 0.004 second after the relay is close, and this time is corresponding to the time constant. So ito palang 0.004 seconds na to, it is also equal to the time constant nitong ating relay. So pag kasi binuksan natin si relay, ang main component niyan ay yung kanyang coil. Kaya itong relay circuit na to, yung first step ng ating ladder diagram, represent an RL circuit. Okay? So yung ating time constant, it is also 0.004. Kaya pag sinubstitute natin ito, these two are just equal. So 1 na lang ito. Ito sila. T is 0.004 and that is also your lambda. So time and
Okay
time.
na, sir. Okay, sir.
Okay, kuha?
Yes, sir.
Okay, so any questions kapatid?
Sir,
Okay tayo?
pwede mag-CR break muna, sir.
Yes, tama lang. Sakto lang. So, coffee time natin ito pag 2:45. Okay, so sige kapatid. Coffee break muna tayo. 15 minutes. So, after 15 minutes, resume natin yung ating discussion. Coffee break muna tayo kapatid. Sarap magkape. Medyo maulan or makulimlim dito sa amin eh. Dito sa Rizal. Nasa Rizal ako ngayon eh. Last time nung mag-discuss ako, nasa Pampanga ako. Ngayon Rizal naman. Ngayon dyan, kamusta panahon? Okay, so let us continue. So let us try number 7. No? So decay naman. No? So again, we have a coil, so RL. So ano naman pinagkaiba ng ating decay? So kanina, kay initiations, we may consider that the current in the given circuit increases. So now, from the term itself, decay, so yung ating behavior, so again, for our RL circuit, now, pagawin ko lang yung position ninyo. So in this case, initially, the given circuit is on steady state. Then by opening the switch, i-off naman natin siya, no? So tawag natin dyan, that is decay transient. So initially, yung ating switch, it is closed for a certain period of time. Then at time equal to 0, so i-open naman natin siya. Okay? So tawag natin dyan, that is decay transient. No? From on position to off position, so we are dealing with decay. So ibig sabihin, so from our initial steady state, so kapag kinuha natin yung behavior ng ating circuit in terms of current, so again, this would be the corresponding time and this is the current. So at time equal to 0, ibig sabihin, no, at steady state yung ating circuit, so matagal nang connected, so yung ating current is still maximum. So ano mangyayari sa kanya? At time equal to 0, current is maximum, then eventually, kaya decay, so the value of current decreases, then approaches to 0 at time approaches to infinity. No? Baliktad naman. Kaya tinawag siyang decay. So the current decreases. So ibig sabihin, yung current na yun, hindi siya agad 0 kasi yung current na yun, that is based on the energy stored in this given inductance that would be totally discharged by our resistance. Kaya the current, that is decreases with respect to time. So therefore, kung gusto natin kunin yung equation of this decay transient or decay current, so at time equal to 0, switch is closed. So pag nag-ABL ka dyan, lalabas that the voltage drop across R plus voltage drop across L, since open na yung ating switch, so that would be equal to 0. So alam na natin kung ano equation ng ating voltage drop across R, that is R times I, L, di over dt for our BL, so equal to 0. So again, meron tayong differential equation. So ito, isusolve naman natin yan using separation of variables. Separate mo yung variable ni I at saka ni T. Ano naman yung ating mga magiging initial value dyan. So kung titingnan natin, at time equal to 0, ito yung ating current. So that is the current which is equal to maximum value which is always equal to E over R. Now, at time approaches to infinity, so yung current naman natin dito approaches to 0. So baliktad sila ng initiation, kaya decay. So therefore, using that initial value, so makikita natin ngayon that the given current or the decay current in this given circuit, it is always equal to whatever the maximum value of current e raised to negative t over lambda. So that would be the equation for our decay current. Kaya as time approaches to infinity here, the current decreases. So therefore, for problem number 7, the decay current of the given coil, that is our RL, so after the switch is closed or open rather at time equal to 0, so palipas tayo ng certain period of time, t sub 1, we have found out that after 2 milliseconds from the time the switch is being open, we have found out that the current in the given circuit is still what? Sabihin natin 10 ampere. Now, let us consider after a certain 6 milliseconds, simula nung i-open natin yan, we have found out that the given current now, I sub 2, it is equal kanino? 3.68 ampere. So, what would be the time constant? Since RL pa rin yan, either initiation or decay, basta RL, isa lang ang formula ng time constant natin. That is only L over R. For that is RL circuit. So how to solve for that? So meron na tayong two equation. Kanina, nagamit na natin itong equation na to. That the corresponding time constant, it is also equal to T1 minus T sub 2. I-divide natin kanina load. Kanina voltage, ngayon current naman, it should be I2 over I sub 1. So saan yan, di ba? Ito, this equation, it is just similar with the voltage across the inductance. No? Kung ito is B sub L, this is the source voltage doon sa ating initiation. Nasaan yun, ano? Ginamit na natin yung equation na yan. Ito siya. Tingnan mo yung equation ng ating B sub L, it is just the same as the decay transient. Okay? Kaya pag kinuha natin yung value ng lambda, diretsuhin na natin, no? Dinerive na natin kanina itong equation na to. Kung given yung voltage drop across inductor, so BL2 over BL1. So since dito given yung decay current, so I2 over I sub 1. Okay? So in that case, pwede ko nang diretsuhin that the time constant for this given circuit, ano si T sub 1, that is 2 milliseconds, so 0.002 minus T sub 2, 0.006 lone, I sub 2 is 3.68 over the given current of 10 milliampere. So the time constant for this given circuit would be 0.002 minus 0.006 divided by load of 68 divided by 10. So meron tayong final answer. 4 times 10 raised to negative 3, or that is also 4 millisecond. So that would be the time constant for this given circuit. Anong letter yan? Ayun, dog style. Okay, kuha ba? Any question regarding problem number 7? So ang gagamitin naman natin pagkuha ng particular solutions of our decay current is using separation of variables dun sa inyong differential equation. Okay? So iwan ko, let us try number 8. So for number 8, a coil of inductance 10.5 Henry is connected to a source. Okay? So ulit, let us consider RL circuit pa rin tayo. Bumalik tayo doon sa from off position to on position. So you have a coil inductance of 10.5 Henry. Resistance, given by resistance. So walang binigay na value ng resistance. Ano lang pinagkaiba? Baguhin ko ito. Yeah. Baguhin ko ito. So this case, yung ating source voltage E or B, bilang ginamit ng SOI na lang, that is a dependent voltage source. Nakadependent siya kanino? Kay time. So the given source voltage E here, it is equal to quantity 3T plus 25.4 raised to 1/2 volts. So that would be the value of our source voltage. Its value, it is dependent with respect to the time elapsed, no, kung gaano ba katagal naka-close yung ating switch. So ano hinahanap? What is the current in the inductor after 5.25 seconds? So let us consider switch is closed at time equal to 0. So let us consider what would be now the current in the given circuit after a given 5.25 seconds from the time the switch is closed. So palagpas tayo ng 5.25 seconds, what would be now the corresponding current? So at this case, walang binigay na data doon sa ating resistance. So let us just consider, at this case, for simplicity, the resistance of our coil is negligible, no? Sabihin na lang natin, its resistance is negligible since walang binigay na value. So meron siya maliit na maliit, so pwede nating i-neglect na lang, no? Or the voltage drop across the resistance is negligible with respect to the voltage drop across the inductance at any given time. Kaya pwede natin siyang i-neglect na lang muna, no? Since walang binigay na data. So therefore, if the resistance of the coil is negligible with respect to the inductance, so pwede nating sabihin that at any given time, since R is negligible, the voltage drop across the inductance represent whatever the source voltage ng ating circuits. Tama ba? So at R is negligible or approximately 0, lumalabas that the source voltage E in the given circuit, it is only equal to the voltage drop across inductance. Okay? So, ano ba voltage drop across the inductance? Alam natin, that is L di over dt. So therefore, ayun yung hinahanap natin. So meron ulit tayong differential equation. So using variable separable or separation of variable to solve for di, so ito cross-multiply ko doon. So lalabas, the change in current, it should be equal to whatever the voltage applied, i-divide natin kay L dt. Tama ba? Yeah, no? So you have di equal to E over L. No? So dt. So hindi siya partial dE. Yung solutions talaga niyan, so para tayong naka-differential equation. No? So you have di equal to E over L dt. No? So you have separate the variable I with respect to E. So therefore, pag kinuha natin ngayon yung value ng current, alam natin the solutions for dE is by what? Integration. So you have to integrate both sides. Integrate natin, then integrate. So kailan natin integrate? Una, at time equal to 0, right? At time equal to 0, so what would be the value of our current? Right? So let us consider, alam naman natin for RL circuit at time equal to 0, current is what? 0. So at any given time t, the value of current, it is equal kanina, I. So lumalabas that the value of our current I equal to ano equation ng ating E? That would be our source voltage E. So lumalabas, ilabas ko na lang itong 1 over L. Ano inductance natin? 10.5 integral yung ating source voltage. That is 3T plus what? 25.4 raised to 1 half dt. Okay? From 0 to anong limit of time? 5.25 seconds. So that would be now the corresponding current in this circuit after 5.25 seconds. No? So the current in the inductance. So pwede na natin ipasok dyan sa ating integration. So 1 over 10.5 na inductance times the integral of 3 alpha x plus 25.4 raise natin kanina, 0.5 na lang. Ano limit? From 0 up to 5.25 equal. Ano lumabas? So the current would be 2.88 ampere. So that should be the answer. Meron ba? 2.88 ayun. Anong letter? This should be cut style. Okay? So, any question regarding problem number 8? So, in this case, na walang data doon sa resistance ng ating coil, so let us just consider comparing to the inductance, negligible yung ating resistance. Nakuha ba? Any question regarding problem number 8? Okay? So, iwan ko si number 8. Let us try now number 9. So, tapos tayo kay RL. So, punta natin si RC. A series RC circuit consists of 40 ohm resistor and uncharged 300 microfarad capacitor. So for problem number 9, so let us consider for RC circuit. Ulit, no? Balikan natin yung initiation from off position. I-on natin siya. Kunin natin yung simple equivalent circuit. Okay, so let us consider no, for RC circuits. So from off position to on, so we have initiation. So you have a closed circuit, so you have now KBL. No? So pag kinuha natin yung ating KBL equation here, so again, pwede natin sabihin voltage drop across R plus the voltage drop across C, that would be equal to the source voltage E. So alam natin, voltage drop across R by Ohm's law, R times I. Now, voltage drop across capacitor in terms of current, that is 1 over C integral of what? I dt. Tama, no? That is the voltage across the capacitor with respect to the current equal kanino? Source voltage E. So kung gusto natin kunin yung equation ng current dyan, at this case, ang magiging methods natin dyan to solve for this one, it is under Laplace. Laplace transform and inverse Laplace. Since hindi pwedeng differential equation ito. Kasi si DE, that is just an equation that contains derivative. So hindi dapat integration. So in this case, Laplace. No? So kung ayaw mo mag-Laplace, pwede natin i-convert ito into differential equations. So pwede, alam naman natin that the current in the given circuit, alam natin, current always represent the rate at which the given charge changes with respect to time. So if we try to express that the value of current in this given circuit represent the speed at which the charge of our capacitor increases, so initially, our assumption that the capacitor is fully discharged, so ibig sabihin, its initial charge, it is what? 0. So, pwede nating express yung value ng I in terms of charge of the capacitor. So, your I is dq over dt. So, pwede kong palitan ito that R dq over dt plus, so kapag si I, pinalitan natin dq over dt, dt over dt cancelled out, integral of dq, that is q. Kaya alam natin, voltage across capacitor, that would be its given charge in coulomb divided by its capacitance equal kanino? E. So at this case, pwede mo na ulit isolve ito ng differential equation. So again, you may compute this one in terms of what? Paul DE. So ano naman ang ating variable dyan? So ang variable naman natin dyan, yung y sa Paul DE represent the charge of our capacitor at any given time, and x represent the time elapsed simula nung i-close natin yung switch. So ano initial value here? So ito nga binanggit natin, at time equal to 0, ang assumption, yung ating capacitor is fully discharged. No? Wala siyang initial charge. So that is, at time equal to 0, the initial charge of capacitor, that is simply what? 0. Okay? So therefore, it will be charged now by this voltage. So as time approaches to infinity, it increases its corresponding value. So ito na ang lalabas na equation natin, that the charge of the capacitor at any given time t, it is equal to whatever the maximum charge that the capacitor may attain, quantity 1 minus e raised to negative t over lambda. Wherein Q sub M represent the maximum charge of the capacitor. Kailan lalabas yung maximum charge na yan? That is at time approaches to infinity. So, at time approaches to infinity, kung babalikan mo, ano nga yung term natin? Disco. Okay? So, kung at time approaches to infinity, capacitor is open. So, if capacitor is open, virtually open, pag nagsukat tayo ng voltage dyan, ano magiging value ng voltage drop across capacitor? Diba, kung naka-open yan, voltage drop here is what? 0. Kasi mataas ang resistance ng open circuit. Kaya magiging voltage lang natin is sino? CE. Kaya lumalabas, the charge of the capacitor is maximum and it will approach at time approaches to infinity. It is equal now sa product ng ating source voltage at saka ng kanyang capacitance. So that would be the value of our Q sub M, or represent the maximum charge of the capacitor, or that is the steady state charge of your capacitor. So kung alam na natin ang value ng ating charge. So kung gusto mo kunin ngayon yung ating current, if you want to solve for the current, ano current? That is the derivative of your Q with respect to time. So you differentiate this given equation. Lalabas dyan that the given current I in this circuit, it is equal to maximum value of current e raised to negative t over lambda. So, yan naman yung ating equation of the current. Wherein I sub m, ito yung maximum value. Anong value niyan? That is E over R. Ang tanong lang dyan, kailan ito lalabas? For RC circuit, current is maximum at time equal to 0. So, maximum si current sa RC circuit pagka-on, no? At time equal to 0. Kasi alam natin, at time equal to 0, ano behavior? Diox. At time equal to 0, capacitor is shorted. So, shorted ito habang nag-charge. So, kung shorted yan at time equal to 0, so the voltage drop across R is simply equal to E. Kaya pag kinuha natin yung current, maximum sa kanya. Okay? Yun ang pinagkaiba ng ating capacitor at saka ng inductor. Okay? RL and RC. Magka-opposite sila ng behavior. Nakuha ba, kapatid? So therefore, pag alam na natin yung value ng charge at current in the given circuit, so no more problem to solve for the voltage drop across R and the voltage drop across C. So lumalabas for this RC circuit, now this given current, it is equal to the maximum value of current e raised to negative t over lambda. Therefore, yung ating B sub R, current times R, so lalabas, source voltage, e raised to negative t over lambda. Therefore, voltage across capacitor, ano voltage across capacitor? Q over C. So, pag dinivide natin ito ng C, so therefore, that is voltage across capacitor. Divide ko to ng C, cancel yung C. So this should be equal kanino? Source voltage E quantity 1 minus E raised to negative T over lambda. Where in our lambda, that is again the time constant. Yun nga lang, for RC circuit, time constant is the product of what? RC. Resistor or resistance times the capacitance. So pagdating kay RC circuit, ayan na ulit yung ating formula. Kung papansinin mo, almost the same lang do sa formula ng ating DL or ng ating RL. Nagbaliktad lang. Kanina, ito yung B sub R, ito yung B sub L. Tama ba? Ngayon, ito si B sub L or ito na si B sub R, ito na si B sub L. Okay, kuha? So, nagkabaligtad lang, no? Kanina, yung B sub C, itong B sub C natin, ito yung voltage drop kay R. At yung B sub R natin kanina, ito yung B sub L. Okay? So therefore, kay problem number 9, hinahanap ng time constant, given na pala yung resistance at saka capacitance. So you just multiply. Okay? Therefore, time constant for this RC circuit, resistance that is 40 multiplied capacitance of 300 micro. So meron tayong time constant. 40 times 300 micro. So ilan yan? 0.012. Yun lang siya kapatid, no? Na-recall lang natin yung kanyang specific equation. Anong letter? Ayun. This should be cut style. Okay? So, any question regarding problem number 9? No? Hinanap lang yung time constant. So, magkaiba ang time constant ng RL at saka ng RC. For RL, L over R. For RC, that is just the product of R and C. Okay? So, number 10. For number 10, an 80 microfarad capacitor in series with voltmeter of 10,000 ohm resistance is connected suddenly to 100 volts DC supply. How long will it take the voltmeter to read 40 volts? So pag kinuha natin yung equivalent circuit, So, para lang tayo merong RC circuit. Okay? So, yung equivalent resistance ng ating voltmeter, so siniris natin si voltmeter dun sa ating pure capacitor. Ang ating assumption, unless otherwise, this capacitor is initially discharged. So, binanggit ng problem, the capacitance of this capacitor farad and the equivalent resistance of our voltmeter in series with this capacitor, that is what? 10,000 ohms. So, hinahanap ng problem, if the given circuit is connected to our DC source of 100 volts, how long would it take? Time ulit. T sub 1, simula nung i-close natin yung switch. How long would it take at which the voltmeter or the voltage drop across the resistance of the voltmeter become 40 volts? Okay? So, gaano katagal bago umabot sa 40 volts yung voltage drop dyan sa ating resistance of the voltmeter? Okay, so we have RC circuit. Nakuha na natin kanina yung ating formula. Balikan mo na lang that V sub R is equal to E, constant E, raised to negative T over lambda. So therefore, using algebra, kita natin that the time it takes, it should be negative lambda ln of the ratio, whatever the required voltage across R, over the source voltage E. Okay? So wala na problema. Negative time constant is RC, 10,000 multiplied 80 micro. Okay, loan, ano required voltage drop? 40, source voltage of 100. So, meron tayong time elapsed no? Simula no, i-close natin yung switch, T sub 1. Okay, so you have negative 10,000 as the resistance times 80 micro times na lang kay loan of 40 over 100 equal. So it would take only for about 0.733 seconds. Yun ang hinahanap ng ating problem. 0.33733 seconds. Anong letter? Ayun ulit. Cut style. Okay, gets? Nakuha ba? Any question regarding problem number 10? Kaya yung transient, pag sinabing transient, mabilisan lang. Kaya naalala ko nung college ako, kapatid, pag nagpa-exam yung aming professor during the transient, dalawa lang yung klase ng exam niya. Now, isang problem or 10 questions problem. Pag isang problem lang ang binigay niya, buong oras, long quiz yun. Long quiz yung 10, yung one problem. Sabihin nun, pagka isang problem lang binigay, at least 2 bond paper back-to-back ang solution. Kailangan mo pang gamitan ng calculus. Nagamitan mo na sari-saring mathematics bago mo makuha yung required data. Pero pagka short quiz, 10 items lang. Pag short quiz, 10 items, 10 minutes. Ganun siya mag-quiz natin. 10 items, 10 minutes. So, short quiz yon. So, kailangan after 10 minutes, tapos na. Tapos, ano yon? Oral. Hindi siya nagbibigay ng questionnaire. Hindi niya rin sinusulat sa board. Oral yon. Babasahin niya lang yung problem. So, ikaw bahalang mag-draw ng equivalent circuit para makuha mo yung circuit kada problem. So, pag nakuha mo yung circuit sa kada problem, so, alam mo na ngayon kung anong formula ang gagamitin mo. So, kailangan, before mag 1 minute, meron ka ng answer kasi susunod na minute, ayun na naman yung second questions. Ganun siya. Pag short quiz, mabilisan lang. Ay, sa iwan ko, number 11. Kaya pagdating dyan sa transient, so formula based, para lumalabas, formula based. Pero dapat alam mo yung analysis kasi baka mamaya bigyan ka ng mga combination circuit. May RL na tapos may RC tapos naka-series parallel pa. Yun ang medyo masaklat doon. Medyo mahaba at computation. Ganon. So number 11. So for problem number 11, a capacitor of 8 microfarad capacitance is to be charged by a voltage of 400 volts through a resistor of 100,000. How long will it take for the voltage across capacitor from its initial zero value to 300 volts? Okay, so we have again same circuit from off position to on position. In this case, we know the value of the resistance in series with this capacitance that is at 100 ohms and the capacitance that is 8 microfarad, which is initially discharged. At time equal to 0, it is connected to our source voltage, which is 400 volts. So, comparison problem, hinahanap ngayon dyan, how long would it take? Isa buwan, no? Simula ng i-close yan, at which, at this case, the voltage across the capacitor will become 300 volts. So, gano'ng katagal bago siya mag 300 volts? So, if voltage across capacitor is 300 volts, therefore, yung voltage drop across R, it should be equal kanino? 100 volts. Kasi alam natin, at any given time, by KVL, whatever the source voltage equals the voltage drop across R and C. So therefore, instead of using voltage across capacitor, gamitin natin voltage drop across R. Para same formula yung gamitin mo as previous problem. Nagets ba? Na instead na si B sub C, o B sub R na lang tayo. 300 ito, so 100 ito. So using the same formula, based on our previous problem, so pwede na natin kunin ngayon that T sub 1, it should be equal to negative time constant. Ano time constant? Resistance of 100,000 times the capacitance of 8 micro. Loan, B sub R, 100, source voltage of 400. So, meron na tayong required time. So, negative 100,000, oops, sumobra, times 8 micro, times loan of 0.25 na lang, no? 1/4. So, it would take only for about 1.111 or 1.11 rather seconds. 1.11 seconds or 1.1 seconds, pwede na, anong letter? Gas time. Ako ba? No, kesa kunin pa natin si B sub C. Kay B sub R na lang tayo. Kasi mas maliit yung formula ni B sub R compare kay B sub C. Okay ko ba? Any question regarding problem number 11? So, iwan ko, no? Let us try number 12. So, for 12, again, we have RC circuit. 200 microfarad connected in series with a 10 ohm resistor. The circuit is connected to 24 volts DC. What is the initial current when putting the switch on? Mas mabilis na ito, kapatid, kung nagets natin yung behavior ng ating RC circuit. So, given that the resistance of this RC circuit, 10 ohms, capacitance of 200 micro, connected to our source voltage at time equal to 0, 24 volts. Ano hinahanap? What is the initial current? So, what would be the value of our current pag initial? That is at time equal to 0. Alam na natin kanina, kapatid, at time equal to 0, ano behavior ng capacitor? Shorted. Kaya at time equal to 0, your current, it is always equal to maximum value of current. Tama? Kaya your I, which is equal to maximum value of current at time equal to 0, which is the source voltage, i-divide mo na lang kanino? Resistance. So you have the final answer. 2.4 ampere. Anong letter? Cut style. Gets ba, kapatid? So basta wag mo lang kalimutan yung diox at saka disco. Hindi ka maliligaw dyan sa mga behavior ng ating capacitor at inductor. Number 13. So for number 13, a current in a 600 volt DC series RC circuit is to be limited to its maximum of 30 milliampere. And the time constant is to be 4 seconds. So calculate the possible value of resistance and capacitance. So again, in this RC circuit, we have to design what would be the proper value of resistance and capacitance. Okay? So, ano yung parameters na kailangan natin consider? If this circuit will be connected across a 600 volts DC source, so binanggit ng problem that the maximum value of current in this circuit, it should be limited to 30 milliampere. So kailangan yan na yung highest possible value of current. And the time constant of the circuit, now this circuit should be operated at a time constant of what? 4 seconds. So what would be the value of our RNC? So unahin natin, alam na natin that the maximum value of current, it is always E over R. So you may compute now that the resistance, it is just simply 600 over the maximum value of current, 30, so 0.03 na lang. No? So 600 over 0.03, so it should be 20,000 or 20 kilo ohms. Now, using the time constant, alam natin, lambda, it is always what? RC. Kaya, we have already compute the resistance. So, capacitance is time constant over the resistance. So, you have 4 over 20,000. So, ilan yan? I-English natin. 200 times 10 raised to 6 raised to 6 is microfarad. So, 20 kilo ohms and 200 micro. So, ay nahanap ng problem. But direct substitution na lang. Basta kabisado mo na yung formula. 20,000 and 200. So, this should be baligtaran. Okay, kuha ba? So, iwan ko yung number 13. Number 14. A 50 microfarad capacitor is discharged through 100 kilo ohm resistor. So, discharge. So, ibig sabihin, initially, this capacitor is fully charged to 400 volts. So, in that case, meron tayo ngayong decay transient in terms of what? RC circuits. So, baguhin ko lang yung ating illustration. Ano? So, from steady state or on position, i-off natin siya ngayon. No? So, yung location ng ating switch, initially, close yan. Then, at time equal to 0, i-open natin, connected to our source voltage. So, at this case, at time equal to 0, dahil initially naka-on yan, that is initially at steady state, so unless otherwise, the initial charge of the capacitor at this case, no, from on position to off position, it should be equal to the maximum charge Q sub M. At ano yung Q sub M natin? That is equal to E times C. Nakuha ka ba? So therefore, let us consider that initially before switch is open, the source voltage is 400 volts. A capacitance of 50 microfarad. It is connected in series with 100,000 ohms. Okay, pag in-open natin yan, no, pagka-open yan, so makita mo yung LED indicator natin, so medyo naka-light pa yan. So unti-unti, yung LED indicator natin, so unti-unti, magdidim na yan hanggang totally mag-turn off. Kasi yung energy stored in this capacitor, it would be now discharged or consumed by our resistance. So hinahanap ng problem, if the capacitor was initially charged to up to 400 volts, determine the energy stored after 600 milliseconds. Required, what would be the remaining energy across the capacitor at T equal to 600 milliseconds. Okay? So, gaano pa kalaking energy ang naka-stored o natitirang energy stored in the capacitor after 600 milliseconds simula nung i-open natin yung switch. Okay? So, para makuha natin yan, so babalikan lang natin ano ba behavior ng ating decay transient pagdating kay RC circuit. Kaparehas lang ng ating decay doon sa ating RL circuit. At time equal to 0, open na yung ating switch. So lumalabas ulit that B sub R plus B sub C equal kanino? 0. Ngayon, alam ulit natin yung ating current is what? dQ over dt. So para hindi na lang ulit mabas yung ating integration, so pwede natin sabihin voltage drop across R, again, that is R, dQ over dt. At alam na natin, B sub C is Q over C equal to 0. So at this case, kung gusto mo siyang isolve, gagamit lang ulit tayo ng DE na separation of variables. So separate mo lang si T kay C. Ito makukuha natin. That the value of the charge, remaining charge of the capacitor, it should be equal to whatever its initial charge, that is Q sub M, e raised to negative T over lambda. Kaya papasin mo, unti-unti, the charge of the capacitor will be totally discharged by the series resistance. Now, as time approaches to infinity, so magsisiro na ulit yan. So therefore, kung meron na tayong Q, alam ulit natin yung magiging value ng current, voltage drop. So again, pag sinog natin yung current, differentiate mo ulit ito. So pag dinifferentiate mo yan, so lalabas din yung ating equation ng current. Or, pag kinuha natin yung voltage across the capacitor, ano voltage drop across the capacitor? Q over C. So in that case, B sub C, it is just equal to E, constant E, raised to negative T over lambda. So this would be now the remaining charge in terms of voltage of our capacitor. Kaya kung gusto natin kunin yung energy stored in the capacitor after 600 milliseconds, kung babalikan natin, energy across the capacitor, it is always equal kanina, 1/2, MB tuloy, no? Kinetic energy yan. That is 1/2 C BC squared. So, ibig sabihin, let us just get what would be the remaining charge of this capacitor in terms of voltage after what? T sub 1. Nakuha ba? Ba't nawala yung 1, sir? Yung 1, subscript lang naman yun. Ibig sabihin nito, itong E sub 1 kasi this energy across the capacitor changes with respect to time. So, this one
Yung, ano sir, may I sir, yung 1
yes,
sa ano sir, sa 1 E pa quantity 1 minus yung Euler tapos raised to negative T. Di ba may 1 man yun sir?
alin ito?
Yes sir.
Okay. Yun, here yun. At what condition? That is from off position to on position. Kaya kailangan alam natin kung ano yung state ng ating system. From off position to on position. Ngayon, baliktad tayo. Dati siyang naka-steady state. Dati siyang steady state. I-off natin. Kaya decay transient. Okay, kuha?
Okay sir. Yes sir.
Okay, so i-open mo yan. Mawawala talaga yung 1. Ito siya. Ito naman yung DE natin doon. No, kaya nilalagay ko kung ano yung state ng ating circuit para alam natin kung kailan ginagamit itong mga equation na to, kung dati siyang naka-on or naka-off or from off to on. Kasi yan ang consideration natin. No? Yung changes of the state of the given circuit. Okay? Kuha mo? Kaya nawala yung 1. Okay? Ito siguro yung hinahanap mo dun sa original formula ng ating RC circuit. Tama? No? Ito yung hinahanap mo, di ba?
Yes sir,
So,
yes sir.
yan. Ito yung hinahanap mo. That is under from off position, i-on natin siya. Talagang meron. Kasi at time equal to 0, shorted pa yung ating capacitor. Pero habang tumatagal, nag-open siya. So palaki ng palaki yung kanyang voltage. So dito kapatid, baliktad naman. So here, yung ating circuit is dating steady state. So unti-unti, madi-discharge yung ating capacitor. So kung madi-discharge yan, so unti-unti, yung kanyang voltage decreases also. Kaya mawawala talaga yung quantity 1. Okay? Gets na natin. Kaya importante, alam natin kung ano state ng ating circuit. Kung dati ba siyang energized tapos i-off natin or dati siyang naka-off, then i-on natin. Kaya palagi nakalagay dun sa akin from on position to off position at yung direction ng ating switch para hindi tayo maligaw kung kailan ba applicable yung mga formula ginagamit natin. Basically, pag dinire mo, differential equation na. Okay? So therefore, no more problem. Kunin lang natin what would be now the remaining voltage or the remaining charge of this capacitor after 600 milliseconds. So either kunin natin yung remaining charge of the capacitor in coulombs at since alam naman natin voltage across capacitor is Q over C. So pwede rin naman ito kapatid maging equation as 1/2 charge of the capacitor at any given time in terms of coulomb, divide natin kanina capacitance. So either of the two equation will do no? The same answer lang. So dito, kunin na lang natin yung voltage kasi alam na natin yung total voltage at time equal to 0 habang hindi pa natin ino-open yan, no, yung capacitor natin from steady state, naka-open yan. Kaya pag nagsukat ka rito, that is the source voltage. Okay? Okay? So therefore, solving for the voltage across the capacitor, BC1, that is at time equal to 600 milliseconds, initially, 400 volts that would appear to its open circuit terminal, e raised to negative, okay, 600 milliseconds, so that's what, 0.6 na lang. Divide, time constant? So time constant, the product of our resistance of 100,000 multiplied 50 micro. Okay, so dito ko na lang ilagay 100,000. So meron tayong voltage across the capacitor. So voltage drop or the remaining voltage or the remaining charge in terms of voltage of our capacitor 400 should E raised to negative 0.6, that is 600 milliseconds, over time constant of 100,000 times 50 micro. So ilan na lang siya? So nabawasan na yan. So 354.77 volts na lang. Therefore, the remaining charge or the remaining energy in joules, that is 1/2 times the capacitance of 50 micro multiplied 354.77 squared. So the unit, it would be in joules. Squared times ko na lang kay 50 micro over 2. So you have 3.1465. Anong unit? This should be in joules. That will be the remaining energy across the capacitor after 600 milliseconds. So habang patagal na patagal, pabawas ng pabawas yan kasi it is discharged or consumed by our resistance. Okay ko ba? 3.14 will do. Anong letter yan? So this should be, okay, gets natin kapatid? Any question regarding problem number 14? Okay, so iwanan ko, let us try number 15. So for number 15, a capacitor has an initial charge of 8.3 coulomb. If the current flows through in it is given by the equation of I equal to 2t plus 3 amperes. So find the charge when t is equal to 1 second. So ano ibig sabihin? Again, let us consider we have RC. Supposed to be RC circuit. Yun nga lang, ulit, no? At time equal to 0, off tayo. Then, i-on natin. However, anong binanggit ng problem? At this case, the initial charge of the capacitor, meron na tayo. In terms of coulomb, it is what? 8.3 coulombs. So at time equal to 0, switch is closed. Now, binanggit ng problem, after the analysis, we have already found out that the equation of the current in this given RC circuit, it is equal kanino? 2T plus 3 ampere. So parang lumalabas, in this given RC circuit, there is another unknown parameters na hindi na binanggit ng problem that affects the equation of the current. Kasi kung RC circuit lang yan, kapatid, no? If we have only RC circuit, kung wala ito, alam natin yung equation ng current. Nasaan yung equation ng current natin, ano? So, ito dapat yung equation ng ating current. So, the value of our current, that is only I sub m e raised to negative t over lambda. However, binanggit ng problem, in the circuit, we have found out that the current, it is 2t plus 3 ampere. So, ibig sabihin, we have another unknown parameters that affect the equation of the current. So, in this case, wag na nating hagilapin kung sino pa ito. Kasi alam natin, for the series circuit, iisa lang naman ang current, which is I. Tama ba? So, therefore, initially, meron tayong capacitor that is partially charged by 8.3 coulomb. So, kulang pa yung charge ng ating capacitor. So, i-charge pa natin ngayon yan by connecting it to a source voltage E by means of resistance and another unknown parameters. So ano hinahanap ng problem? What would be now the total charge of our capacitor at T sub 1 equal to 1 second. So after nating i-close yung switch, kunin natin or palipas tayo ng 1 seconds, what would be now the total charge in coulomb by our capacitor? Parang ano lang din naman yan. Same idea. So medyo lobat na yung ating cellphone. Medyo let's say 25% or 20% na lang yung kanyang battery. So ipa-plug in natin siya. So di ba kapatid, after mo siyang i-plug in using the charger, so after certain minutes, madadagdagan yung kanyang charge. So anong ibig sabihin nun? To get now the total charge of our capacitor after 1 seconds, it is always equal to whatever its initial charge plus the additional charge that this capacitor gained after what? 1 seconds. Okay? So, kailangan natin makuha ngayon what would be the charge gained by this capacitor after 1 seconds after the switch is closed and connected to this given source voltage that produces a current of what? 2T plus 3 ampere. So, ang tanong ngayon dyan, paano natin kukunin itong charge na to? Although we have the equation for the charge of our capacitor from off position to on position, nasaan yun, no? Yung dinerive natin kanina, ito siya. The charge of the capacitor, Q sub M, quantity 1 minus e raised to negative t over lambda. However, take note, this equation, it is only applicable kung ang circuit lang natin is simple one, RC circuit. Wala tayong another parameters that affects the equation for this current. Tama ba? So we cannot apply this given equation. So kung hindi mo magagamit ito, saan natin kukunin itong Q sub P? Alam na natin kapatid that in this circuit, iisang current at alam natin this current also represent the rate at which the charge of the capacitor changes with respect to time. So, ibig sabihin, in this given equation of the current, this current I also represent the rate at which the charge of the capacitor increases with respect to time. Kaya kapag kinuha ko itong Q sub T using variable separable, dq is equal to I dt. So therefore, pag in-integrate natin yan, kapatid, okay? So sino lang itong Q na hinahanap natin? That is the additional charge gained by the capacitor from time equal to 0 up to 1 seconds. So, ibig sabihin, at time equal to 0, i-connect pa lang natin yung ating circuit sa source. So, ibig sabihin, hindi pa nadadagdagan itong charge niya. So, kung hindi pa nadadagdagan yung kanyang charge, ano yung kanyang initial or yung kanyang charge gain by this given voltage? So, since i-connect pa lang natin siya, its given charge gain, it is only what? 0. So, after certain period of time t, so its given charge, it is equal na kanino? Q sub small t. So, itong small t na to represent that is only the additional charge gained by this capacitor after niyang i-connect sa ating source voltage. Gets ba, kapatid? So, therefore, pwede na natin kunin ngayon that the charge gained by the capacitor after it is connected to our source, it should be equal to the integral. Ano yung ating current? 2t plus 3 dt. Anong limit? Simula nung i-on natin yung switch up to 1 seconds. So, kuha natin what would be the corresponding charge it gained after 1 seconds. So, pwede natin ipasok sa integration to alpha x plus 3. Limit is from 0 up to 1. So, after 1 seconds, it gained additional 4 coulombs. Tama ba, kapatid? Therefore, after 1 seconds, ano na ang kanyang total charge? Initially, ilan siya? 8.3 plus 4. So you have 8.3, its additional charge, plus it gained another 4 coulomb. So all in all, its charge now after 1 seconds, it is now 4 or 12.3 coulombs. Gets, kapatid? Anong letter? Balik na. Ay, kuha ba? Any question regarding problem number 15? Gets ba yung ating problem? Although from off position to on position, however, merong unknown parameters that affect the equation of our current. Kaya babalik tayo sa original definition ng ating current to determine gaano ba kabilis mag-increase yung charge ng ating capacitor. Gets ba? So, iwan ko si number 15. Pwede kong kunin si number 16. Voltage across a 20 microfarad capacitor varies with time as given by 10.75 minus 1.5 e raised to negative 1000 volts. What is the current through the capacitor? So, almost the same ng previous problem. Okay? So, balikan natin from off position, i-on position natin. So, at this case, initial charge of the capacitor is 0. Anong ginawa natin? Sinukat natin yung voltage across the capacitor. And we have found out that the reading of the voltage across the capacitor can be determined by this equation. Lumalabas, the voltage across the capacitor at any given time based sa problem can be computed as what? 10.75 minus 1.5 e raised to negative 1,000 t volts. Okay? So, yan daw ang naging equation ng ating voltage across the capacitor. So, ibig sabihin, kapatid, same as previous problem, there is another unknown parameters in the given circuit that actually affects the equation of the voltage across the capacitor. Kasi alam natin kung RC circuit lang yan, hindi ganyan yung ating equation ng voltage across the capacitor. Tama ba, kapatid? So, ibig sabihin, at this case, for simplicity, we have another unknown parameters in the circuit. Hindi natin alam kung anong klaseng parameters yan that affects the equation of the voltage across the capacitor. Kasi dapat ito is source voltage A quantity 1 minus e raised to negative t over lambda. However, binanggit ng problem, ito na yung naging equation ng ating voltage across the capacitor So possible, meron tayong unknown parameter here, or the other option, yung resistance of the capacitor is negligible, then meron tayo dependent voltage source. No? That is also possible. So dito, sabihin na lang natin, we have another parameter that affects the voltage across the capacitor. So ano hinahanap? What is now the current in the capacitor? Eh, since series lang yan, it represents the current in the circuit. What would be the current in this circuit? I, sabihin natin I sub 1, at T sub 1, which is equal kanina, 1 milliseconds. So after 1 milliseconds, ano kaya ang magiging current sa ating circuit? Although alam na natin yung equation ng current kanina, I is equal to I sub m e raised to negative t over lambda. Take note, this equation, it is only based on pure RC lang. No, pure RC, tas constant yung source natin. Eh dito kapatid, we have another unknown parameters. Pwede nating i-consider yung circuit, merong unknown parameters, or yung ating voltage source is dependent. Kaya nagbago yung equation ng ating voltage. Nakuha ba kapatid? So we cannot use this equation for this particular problem. So saan tayo pupunta ngayon? Babalikan natin yung voltage drop across the capacitor. Alam na natin that at any given time, voltage drop across capacitor, it is always equal to 1 over C integral of what? I dt. At any case, hindi magbabago yan. General formula ng voltage across the capacitor yan. So therefore, kung gusto natin kunin ngayon yung current, paano natin tatanggalin yung integration? Ano kabaligtaran ng integration? Gagamit ka ngayon ng derivative. So you take now the derivative of both sides with respect to time. Anong lalabas, no? So you have now the change in voltage across the capacitor with respect to time equal to 1 over C integral derivative of current is di over dt multiplied kanino dt. Kaya pwede natin i-cancel itong dt. Integral of I, that is simply, or integral of di, that is simply I. I-divide natin kanino capacitance. So, ibig sabihin, the change in the voltage across the capacitor, it is always equal to the ratio of current over its capacitance. Kaya kapag kinuha natin si current na yan, that is simply capacitance multiplied to the derivative of the voltage across the capacitor. Ano yung voltage across the capacitor? Ayun. Substitute natin. Kailan natin kukunin si current? After 1 milliseconds. Okay? Kuha ba kapatid? So, pwede na natin i-substitute. So, we have the capacitance of this capacitor. According to problem, this is 20 micro. So, meron akong 20 times 10 raised to negative 6. Kunin mo yung derivative functions ng iyong calculator. Ipasok natin ang equation ng voltage 10.75 minus 1.5 e raised to negative 1,000 t. Ano limit at t equal kanino? 1 milliseconds. So that is 0.001. At saka mo equal, that should be the current in the circuit. Okay ko ba? So let us counter check. Micro times derivative. 10.75 minus 1.5 shift e of negative 1,000 alpha x. So x represent the given time elapsed 0.001 or 1 milliseconds. Tsaka mo equal, so meron tayong sagot. So the current in the circuit will be 0.01104 ampere. That should be the answer. 0.011 ampere, pwede na kapatid. Anong letter? Ayun, cut style. Nakuha? Any question regarding problem number 16? Oh, yun siya kapatid, di ba? Ganun lang naman siya. Ayun nga lang, pagdating kay transient, kailangan talaga since ang analysis natin diyan, no, ang binabantayan talaga natin diyan yung change of state ng ating circuit. Kaya dapat alam natin kung ano ang kanyang initial state, kung dati ba siyang energized or dati ba siyang naka-shutdown, no, para alam natin what would be the behavior ng ating parameters na kailangan bantayan. Ang binabantayan lang naman natin parameters diyan ay yung ating inductance at saka capacitance kasi sila yung mga parameters na merong kakayahan na makapag-store ng energy that directly affect the behavior of our circuit. Nakuha ba, kapatid? Any questions? So I think yung remaining problem sa inyo na yon, kapatid, ano? Sa inyo na to. So kayo na bahalang mag-solve ng 4 na natitirang problems. Okay, nakuha ba? So the idea, hindi kayo lalayo sa ating simpleng network analysis, no? KBL, KCL, but take note to get the equation of the current. Tandaan nyo yung behavior ng ating inductor at capacitor. Then, yun nga lang, differential equation. Yun nga lang, DE talaga. Ayan. 17 a time of the milliseconds. So, ang sagot dito, bigay ko yung final answer. This should be letter C, 0.583 microfarad. Number 18, 1065. Sagot. So, ilagay ko na lang dito yung final answer. So, you try. Number 17, the answer would be cut style. Number 18, the answer would be baliktaran. Number 19, this is just objective baliktaran. Number 20, so number 20, ano nga ba sagot dito? Sinod ko na ito eh. Silipin ko yung sagot ko, ha? Nalimutan ko yung sagot eh. Okay? Ayan yung remaining answer. So, C, B, 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 B. Okay. Baba? So, any more questions, kapatid? So, ganun pa rin yan. May weekly test ba bukas, sir? Aha. So, in terms of evaluation exam ninyo, so ito is based do sa aming hawak na mga in-house review for schools, ano. So pagdating sa mga evaluations, kung sa actual review sa amin, no, sa Powerline, kami talaga ang nagbibigay ng evaluation exam every after ng 3 sessions. So sa inyo, sa school, kasi kami is, kumbaga, parang outsourcing kami. No? Kami yung, dito,